All right, let's talk about a tool that's basically been the secret ingredient in software development for, gosh, almost 50 years now. It's called GNU Make. And yeah, we're calling it the master recipe that's been cooking our software since 1976. So let's get right into it and see what makes this thing tick.
So put yourself in a developer's shoes for a second. You've got hundreds, maybe thousands of different source files, and they all need to be compiled and linked together perfectly to create just one program. So how do you even begin to manage that? How do you keep it from turning into just total chaos? Well, before automation, it was exactly what you'd expect, a complete mess. I mean, developers had to sit there and manually type out every single compilation command for every single file. And you know what happens, right? You forget one, you type one in the wrong order, and boom, the whole thing just fails. It was painfully slow, super tedious, and just a recipe for disaster. And that really sets the stage for our first section here, the compilation chaos. Because, you really have to understand the problem to appreciate just how elegant the solution was. And wow, this slide just lays it all out, doesn't it? On the left, you've got that manual hell we were talking about, just typing command after command. And on the right, automated bliss. One single word, make. How in the world did this one little command replace all of that work? Well, that is exactly where Make enters the picture. Let's dive into this incredibly elegant solution. And yeah, thinking of it as a master recipe book for software is the perfect analogy. So at its heart, what is GNU Make? It's basically a utility that reads a list of instructions and then, well, it just figures out what needs to be done. But here's the real genius part. It's smart enough to only rebuild the pieces of your program that have actually changed. This one feature alone saves a huge amount of time. And this thing has such a cool history. It was created way back in 1976 at the legendary Bell Labs. I mean, the place where everything was invented. The version that we all use today, GNU Make, was developed a bit later by Richard Stallman, and it quickly became the absolute go-to standard for building software on Unix and Linux. So, okay, how does it actually do all this? Well, the magic is all contained in its recipe book, which is just a simple file called a Makefile. And every rule inside that Makefile breaks down into 3 simple parts. The cooking analogy really is perfect. First, you've got the target. That's the final dish you're trying to make. Then you have the dependencies. Those are your ingredients. And finally, you have the command, which is just the recipe, the instructions on how to put it all together. Okay, and here's what that looks like in actual code. See that? The app is our target, our dish. What does it depend on? Well, its ingredients are main.o and utils.o. And the instruction, which has to start with a tab, that's important, is the GCC command that tells the computer exactly how to mix those ingredients together to get our final program. But it gets better. Make isn't just about these simple little recipes. It has some amazing hidden superpowers. We can call them the chef's secrets that make it way more efficient and scalable than you'd think. First up is one of my favorites, variables. Just look at the before on the left. You see how those compiler flags are just repeated over and over again? It's a mess. Now look at the after on the right. We define them just one time as variables like CC and C flags. Now we can use them everywhere. And if you ever need to change a flag, you just change it in one single spot. It is so much cleaner and way easier to maintain. All right, next up, pattern rules. Now, this is where Make gets really smart. Instead of having to write a separate rule for every single C file you have, you can just write one single generic pattern. This little bit of code here basically tells Make, hey, anytime you need to create an object file, a .o file, here is the recipe for how to make it from the matching .c file. For big projects, this is an absolute game changer. And speed? What about speed? Check this out. With one simple little flag, you can tell Make to build, say, 8 files all at the same time, in parallel. If you've got a modern multi-core computer, and who doesn't these days, this can just slash your build times. What used to be a go grab a coffee break now turns into just a few seconds of waiting. It's awesome. And finally, let's talk about phony targets. This is a really important concept. A phony target isn't a file, it's an action. So a target named clean isn't trying to create a file called clean. By telling Make that it's phony, you're saying, hey, this is just a name for a command I want you to run, like, deleting all the temporary files after a build. Okay, let's be real. This tool is almost 50 years old. So is it still even relevant?
The answer is a huge, resounding yes. Let's talk about why this old recipe is still very much on the menu in the modern world.
The magic here is that Make is completely language agnostic. It honestly doesn't care if you're compiling C code or doing something totally different. At the end of the day, it's just a really good task runner, and that's why you see developers today using it for everything. Running Python scripts, building Docker containers, managing infrastructure tasks, you name it.
And this is a perfect example of how it fits into the modern world. Think about a CI/CD pipeline, like in GitHub Actions. You don't want to clutter that up with dozens of complex, hard-to-read commands. No, you just call make. A simple make all to build everything, a make test to run all your tests. It acts as this beautiful, simple, universal wrapper for your entire project's workflow.
And that really gets to the core philosophy behind Make. It's more than just a tool, you know? It's really about an enduring, powerful lesson in engineering elegance.
Now, let's be honest. Are there newer, fancier, more complex tools out there like CMake or Bazel? Of course. And for absolutely massive projects, they have some really powerful features. But just look at this comparison. Make's superpower has always been its simplicity. It's a straight-up text file. It gives you direct, explicit control over everything. And you know what? Sometimes that's exactly what you want and need.
And that simplicity, it perfectly embodies that timeless Unix philosophy. Do one thing and do it well. Make doesn't try to be a Swiss Army knife. Its job is to automate builds by looking at dependencies and file timestamps. That is it. And it does that one job absolutely perfectly. So I'm going to leave you with a question to think about. Make is one of these simple, powerful tools that has been a quiet, invisible foundation of our software for decades. And it just makes you wonder, right? What other simple tools are out there forming the invisible foundation of our digital world, just doing their one job perfectly, day after day?